working in a project with development mode, working in a project in a kind of feature maintainability mode. Feature maintainability in the sense that kind of enhancement or bug fixing is software is available. Whereas in development, software is not available. Means someone is developing the software from the scratch. So in development mode, a developer need to include many libraries. Where in maintainability code, the developer has the software. So in both cases, a developer needs to know about the either library package or the current software. If we see Python is kind of loosely, or it doesn't have any explicit type, function signature, class attributes, module attributes, wherever you see. The variable they do not have type. Means Python understands and it instantiates the typing implicitly. Programmer can explicitly declare a variable, but not required. Means there are kind of notations through which, like if it is double quote, then it is a string. Otherwise, if it is kind of a decimal number, then it is an integer or it is a float. So problem is, so if I am developing a software or I am kind of maintaining a software, how I should proceed? That is a big task. One work is that I can go ahead and I can just look at the library package if I am developing, or if I am maintaining the current software packages and source code and class code. It's a multi 10,000 lines of code that I need to understand before I start. It takes months. Like any widget programming, if I need to use a widget, then I'll go with the widget class, then search here and there all the derived classes, then think about its kind of usability, means which widget I should use. In Python, adding to a class data structure or adding an attribute to the class instance is runtime. You can add in any methods, in any function. You can kind of grow your class data structure, class instance data structure. Reading code is kind of cumbersome. So what is the solution? Solution is that I should know the design of the library package or design of the current package in advance. If I have the design package, means kind of package diagram or class diagram, interclass diagram, interpackage diagram. So these are called kind of UML schematic diagram or kind of architectural diagram. So rather than going inside the code and picking here and there, it's very nice that if I start my work, rather than investing weeks or months in understanding code here and there, we can have a kind of architecture in the hand. I can take printout of the architecture. I can just browse on my mobile. So if I need a particular class to be used, just I can browse the class diagram, interclass diagram. Inside the class, if I narrow down in few classes, I can just browse through the attributes and its methods, and I can decide, okay, so at this place, this class, I need to instantiate. So class diagram, package diagram, I need to have in my hand. So how I can proceed? I am writing a code, library package or the current software architecture, how I can do it? I have Python source code. Python source code is not a big deal. Means if I install a software in Python, Python source codes are available. I mean, they only execute. Or if software includes a shared library, then Python code means for famous library, anyway it is available on GIT Hub, code repository or something. So getting a source code in Python is not a kind of a big issue. So if I have a Python source code, a solution is there any tool or software that would kind of parse the Python code and give me the architecture? I did not go all the places and see that if someone is attached to self or someone is attached to the class data structure or something like that. It's not C++, where the initialization generally happens in the constructor or something. Anywhere kind of attribute initialization or attribute addition can happen. So if I get to have the architecture of the class of the library package or the current package, it is a kind of a boom. Means you can start immediately if you have the blueprint of the architecture. So we'll see the Pyreverse tool that parses the Python code and then it generates the kind of architectural blueprint, package diagram, class diagram, inter-class relationship, everything is there. There are few things that is lacking in Pyreverse. Like in a class diagram, we don't have the derived classes, only the kind of parent classes are there. Kind of, we can have our own software that uses the Pyreverse, and whatever is lacking, that you can fill in. Just run the tool in 1 hour, 2 hours, full architecture is there. Just use the architecture kind of in PDF format or something. You can just, when you are free, you can just sit and browse the architecture. Start using. So we'll see that how in a reverse engineer we can generate the UML architecture, class diagram, package diagram, and interrelationship through Pyreverse and any tool that is using the Pyreverse. That means.
Further discussion on the generating UML diagram through reverse engineering of the Python code through tool Pyreverse. So we'll proceed on desktop. This is Linux Mint. So Pyreverse is a kind of a Python tool which parses the Python code and it generates the designing, primarily package diagram and class diagram. So these two it generates. Okay, so Pyreverse is Python code reverse engineering tool. It generates class diagram and package diagram. Okay, so package diagram in the sense that a package contains sub-package and a sub-package contains another sub-package or it contains module. So interrelationship between the package, sub-packages, modules means up to module level. So that comes under package diagram. Inside a module, inside a package, sub-package, if it draws a class relationship, then it comes under class diagram. So that is the idea. Okay. So it draws the modeling element. Modeling elements are kind of, these are the drawing elements that create relationship among classes, primarily in the class diagram. So like generalize, kind of this is can be considered as inheritance. Okay, so this is kind of realization of an interface also. In containment, aggregation, composition, dependency, if one class is dependent upon another class. Okay, so dependency is kind of it's a simple form of minor form of containment. I mean aggregation. Association, if one class is related to another class but it's not dependency. Okay, so like so many, one student, one tuition, one class, kind of one teacher is associated with many other teachers. Okay, one teacher is associated with many students. So this is not dependency, this is kind of association, loose form of association. Tight dependency will become kind of aggregation, little loose dependency and no dependency but relationship is there, that comes to association. Okay, so nice. So Pyreverse draws so many things and it is a kind of a God-gifted boon where someone just when we start the code, writing code, and immediately we get the kind of design of the software. So means it's like something dream comes true. So it is in that fashion. So how Pyreverse can be installed? So it can be installed through packet manager or preferred installation package, I believe so, pip. So someone can install it through package manager or someone can install through pip manager. Okay, so preferred installer program is pip. So both way someone can install. Okay, so no need to add some repository or something like that. So plain way it is installable. So SciPy, the package for which we'll see the example. So scientific Python. So scientific Python can be installed through Python 3 SciPy. Okay. Source code of SciPy is available at GitHub through this path. Okay. If we install anyway other than Python code, anyway it's available. But if we download the source code from GitHub, so Python and Python both code comes. So Pyreverse handles only Python. Okay. So we have kind of modified Pyreverse where it handles Python code also. We can check Pyreverse and SciPy versions. Okay, so Pyreverse help we can print what it does. So Pyreverse, it is kind of we can pass the module list or we can pass direct the directory, package directory. Okay, so mainly in any class diagram, we see the level of inheritance, how many level inheritance we want, that is -a, -s, level of association. Okay, so if we want all inheritance, all associations, module name, kind of full path of the module from the library, kind of the topmost directory till the module name. So full dot name if we want, we'll say yes or no. -k is for kind of just only the name of the class. -c class name if we put, then okay, -k only name of the class, -c class name it would put attribute and methods also. Okay, so how many level of ancestors we want, association, how many levels we want, and module wise what is the module format we want. If we want full format, full path, Y, otherwise no, and same K and -C what we described. Python path, it's a good idea to set Python path where the package exists. Like if package is installed in this directory. If this directory if this directory is not available in the Python path, then package this directory should be added to the Python path. So that is the idea how these are drawn, so that we can see. Okay, so these are drawn in this fashion, like okay. So if I have a code like this, like I have a directory called base, and base init file is there, and base package 1 and package 1 package 2, and then we have another package 1. So package 1 init is there, package 1 package 2 init is there. Inside package 1 package 2 there is a module file, and inside package 1 there is a module. So this is what I have written a code, and if I draw the diagram, package diagram would be like this. Like base is a package, a kind of a base package, super package. It contains package 1. It contains, so this is kind of, this relationship is a dependency relationship. So base is dependent upon package 1, package 2, package 1 and package. So these two package, so if you see the code of the base in it, okay, so it import package 2, from package 1 import package 2, from package 1 package 2 import module 2, and from package 1 package 2 module 2 it import B. So indirectly it is dependent upon this one, it is dependent upon this one, and it is dependent upon this one. This is what it is showing. Same way the rest of the file is like that. So this way it draws the package diagram. Base is kind of, it is dependent upon these three, and package 2 dependent upon these two, and package 1 depend upon module 1 and package 2. Okay, so there is a class. So this class diagram also it shows where class A is in package 1 module 1A, and package 2 module 2 derives from it, and package 1 module 1B also derives from it. So these two diagrams primarily draw package diagram, how packages are related to each other, and then after that how classes are related to each other. Okay, so we will kind of do whatever we want. So we'll go ahead and install the Pyreverse the way we are kind of talking. Okay, so we'll go, so we have to install the sudo apt get install pylint, this is the name. Okay, so it is installed 2.1.2. We need to install GraphViz also, because that draws kind of a PDF. GraphViz, it is installed, so we can check the version. Now we'll install SciPy. So sudo apt get install SciPy Python 3 SciPy. Okay, so it is installed. I can check everything, dpkg -l, egrep -e, and pylint, and then SciPy and GraphViz. Okay, so I'll say -i. Okay, so GraphViz is installed 2.42 and PyLint and Python 3 SciPy. So this is our work business. Now we can download SciPy from the Git Hub sklearn repository. Okay, so that we'll see. Whatever we have, we'll try to work with that. So we'll say dpkg -l Python 3 SciPy okay, so visibility is more. Okay, so package name is SciPy and package name is SciPy and it is installed in this location. Userlib Python 3 dist packages. Okay, so this path must be in the Python path. We'll check if it is not there, then we'll set. So I can say Python -c and import sys print sys dot path. Okay, so userlib Python 3 dist package is already available in the path. So I think setup is done. So we can start. So idea is we want package diagram first. Okay, so we want package diagram first. We'll create a directory mkdir Pyverse SciPy directory is completely empty. Okay, now Pyreverse help, if I type, then we get the same thing. What we talked, -h for help, -f what mode we want. So kind of this is filtering, special mode, other mode, all mode, pub only mode. Okay, so current mode is public only, so public attributes it would show. Okay, -c class name, if we give then class everything it would print. Current it is not set. -a level of ancestors, -capital A all ancestors, -s association level, -capital S all association level, -b show built-ins, -m okay, so what is the module we want? Complete module name, y or only short form, -k only class names, only skeleton, and -o what is the output format? Colorized, it will show in colors. Okay, how many color depth we want? Okay, so how many separate color will be used? Ignore, if you want to ignore a particular file, like there are many files that comes in test directories, so we can ignore test. Okay, name of the project. Okay, right now, so we can choose the name of project and output directory where the output would go. So so it would dump on the current directory only. So that is the idea. Now we'll proceed with the package diagram. So I can say Pyreverse and we have to choose userlib Python 3 dist packages SciPy. Okay, now if I type this, then complete package diagram it would draw. So we'll try. if it's okay. So I'll say minus a minus s my. If it hangs, takes too much time, we'll cancel this. And we kind of will say ignore test, and then output format PDF. Okay, so I don't think anything else we need. Okay, it would parse complete directory and it would give a kind of a package diagram. If it is stuck at a place for more than 10 seconds, then we'll cancel it, because we are doing something that is too big. Okay, so quite optimistic. Okay, so ND image, we can see that it is taking time. We'll wait for 10 seconds. Then we'll cancel it and we'll proceed with the single level of association. Right now we have placed, okay, so we'll cancel it. So it is taking too much time. So there is nothing. Okay, so I'll say minus s minus a. Here it would be clear. Minus a minus s, one only, and minus y. Let's try our luck with one level of association. If it doesn't work, then we will leave the idea of generating the package diagram from the top directory, and in a kind of a user is trying and he has a lot of time, then he can try from the top of the directory. Otherwise, we'll try any sub package. Okay, so again it came to ND image and morphology. We'll wait for 10 seconds. Okay, so it would take a lot of time. I think in spare time, when we are not busy, then we can just run it, okay, and let it take time. But here we can't wait, so I'll cancel this. Okay, so still we do not have anything. So we'll try creating for a sub package. So sub package, what we'll choose now, SCIPY, and sub package kind of we'll try spatial. Okay, so this sub package we'll try. Okay, it should pass through because nothing very special we have kind of placed any. Okay, so it passed through. Now we have two files. One is package, this is what we are interested in. Okay, so this is the package diagram. This is package diagram. SCPY spatial is dependent upon the geometric slurp, KD tree, plot utils, spatial pro crushes, and something like that. How it comes into the picture? We can browse the code. So user lib python 3 dist scipy spatial and init. We'll search for kind of import. Wow. So from KD tree, import everything. From CKD tree, from QHull, from spherical, from plot utils. So this is what it is doing. Okay. So from spatial KD tree, so KD tree is here. Okay, and if it is not here, means the directory doesn't exist or something like that. So whatever exists here, that is shown. So plot utils. Oh, it's there. So plot utils. We have geometric. Oh, it's here. Okay, so kind of procrust, so it's here. So how it works is we can open the init file and we can see that which all kind of directories, which all packages it is dependent upon. The way we saw here, like in the init file we are importing, and that way it is also doing here, and it is generating this diagram. So this is a package diagram. Probably it is not very big, or we can try for bigger one. Anyway, we'll see the class diagram. Okay, so this is class diagram. So nice it is. So this is a kind of panoramic view of all classes in a package, SCPI. Okay, dependency and inheritance, dependency, inheritance, containment, everything it is showing. It's very big. We can colorize it if we want. So I can remove everything and we can colorize it. So I can say colorized. I can say I think that's enough. Okay, so it is done, and if I do class, it is in color format, too good, too nice, and every kind of a group of classes are in different color. So this is the class diagram. We can draw for kind of little more prettier. We'll try for in SCPI we can try for interpolate. Here Interpolate. Okay, so it should come. Okay, not bad. Oh, it has come. Okay, it would try to do with some SO files also, so that we should not bother about. Now, if I see package diagram, so this is the colorful package diagram, and we are here, SCI, Interpolate, and this is how each are interrelated. I mean, it's so informative. I mean, just looking at this, we can see that what is the scenario. How one package is related to other package, which calls one package, which package call other package. One package is called by how many packages. So nice. And if we see class diagram, okay, so it is quite big. So many classes, and okay, if we want built-ins also, then we can say show built-in. Okay, we'll try with kind of other one. So this is interpolate. Okay, so let's move with the same. It would take some time. I think 10 seconds it takes. Okay, it is done. So now we'll see the class PDF. Okay, so built-ins like dict and whatever comes in built-in package it would show. So it is very big, like float and int. Those. So this is package level diagram is kind of too intricate if we show the built-ins also. So I don't think this is of any use. We can print non-colorized and non-this and only a skeleton. I don't want kind of minus k full property and attributes and methods. So only a skeleton. That also we can do. Okay, done. So we'll see class diagram now. Okay, so pretty only skeleton comes, so nothing more. So only class names are printed. So this is kind of package class diagram. Okay, so we are seeing the package. Down the package we have sub packages. So this is the way for package, sub packages. Okay, we don't have anything. This way we can go for kind of file name. So I can say interpolate if there is any file here. Okay, so we'll see the classes in the file in interpolate. Find user lib python 3 dist packages SciPy interpolate. Okay, and okay, so here many files are there, so we can just find all the .py here. There are many py, we can select anyone. So here we can just xargs and e-grep minus e beginning class. Okay, so there are so many classes. Polyint has 4 classes, whereas feedback has many classes. We'll try with the feedback. So whatever we did now for the packages, so I'll say, okay, I'm sorry. So here, okay, so there is nothing in this directory, ls nothing. So now for the packages, same story, we'll do user lib python 3 dist and interpolate SciPy interpolate, and then the file name, what I think it was poly. Okay, minus ASMY and minus O PDF. Ignore, so test is not, we'll say colorized and show built-in. Okay, now it is generating kind of a class diagram. Since this is a module, so package diagram probably doesn't make much sense here, because module file typically it contains classes. Let's see if it kind of continues, otherwise we'll go for a single level association. Okay, so I believe it is taking time, and we'll try another one, feedback. Feedback dot feedback2.py. I think this is what we were trying for when we were printing the class feedback2 it was. Okay, so we'll try feedback2 and show built-ins. Now we'll don't try our luck and we'll say association level as 1 only. Now see. Okay, so now we have only one classes.pdf, and this is the class diagram it prints. I believe this is too much colored. I can try again with not colorizing it. Okay, so we'll see. Oh, so nice diagram. So this is module diagram. In a module, these many classes exist and how they are related. So pretty. There is no package diagram, but in module diagram, how classes are related to each other. Okay, like we have a spline class, and it derives from built-in object and means how it is related. There is another univariate spline, I think interpolated univariate spline, and that is derived from it. Means whatever we want. So it is like this. Okay, so we can, this is the class diagram, and if we don't want, we can avoid showing the built-ins. Okay, much prettier, no built-ins. So this is kind of a clear-cut diagram, and very nice it is. Okay, so in a particular module, these many classes exist and they are related like this. Okay, so we can try with so we started with the package diagram, and we are in module diagram, package, module. We can try a class diagram. So I can remove everything. There is nothing. So Pyreverse user lib Python 3 dist packages and SciPy and -a -smy -opdf -c. In this, okay, -scpy. So we'll go till module spatial. Okay, so module is KD tree -c. Okay, which class I want? I believe there is a class called KD tree. We'll try. Okay, there is no class called KD. Oh, okay, so this is the way it would do. So class diagram would come with the class name itself, and this is a class diagram in a module. So we started with the package, sub-package, module diagram. Now this is a class diagram. If I have a class called KD tree, then this would draw like this. This is a class diagram. Now we can have many variation in this itself. Now I want colorized, or if I don't want colorized, then show built-in. Okay, so there is no built-in, but see how perfect it is. And like what we showed now is every class it is showing a kind of properties. So if we don't want properties, we can just say -k. Only a skeleton, only high level diagram. So we can generate class level package level diagram. We can generate module level diagram. We can generate a particular class, and we can generate further in the kind of. So we'll generate kind of. For the classes, okay, so we'll see the kind of a big package. So this is all about Pyreverse. There are few problems in the Pyreverse. Like we saw limitations in Pyreverse. Like if I draw with -c, or I think I can go for a kind of a bigger one, that is SciPy optimize. Okay, so optimized and differentiate and okay, so this is I think package name. Functions.py, and we'll try a class name called linear vector function. I believe this is a class name. Okay, I think it is big. It is taking a lot of time. So what I would do is I would cancel this and I'll go with a single level of association. Okay, better. So there is single. Okay, it generated this file, linear vector function. This is the problem with Pyreverse. If classes relationship is big, okay, in that way it prints big diagram. Now it's cumbersome, like where I have to see every class's property and everything is listed. And to kind of to escape that, I can just say -k, then all gone. Okay. Only a skeleton. Either we see skeleton or we see full thing. So there are other limitations also, like we can see that there are too many kind of too many this containment is there, not required this much. So these make unnecessary bloating of kind of bloating of a class diagram. So we have kind of modified this tool, and we have so I'll copy this. So I have a file called pyreverse.py. Okay, so this is kind of we have developed, and it fixes the Python and fixes Python code also. So it provides supports for the Python code also. And after that, it draws the diagram neatly. It generates many diagram and create a kind of clubbed PDF file where we have everything, like whatever we did. So I'll remove everything now here, Okay, there is nothing now. So I'll execute, I'll copy this file again. So I have this file. I can just say Python Pyreverse hyphen fix. So it would execute, it would kind of settle down Python code also, and SciPy. So this will fix this. So this is the path name and this is the package name. I don't think anything extra is required. Okay, nice. So we have now SciPy directory, and it contains all the code with fixed and everything. So the way we want. Now whatever we generated now, like whatever the command we gave. Okay, so for a particular file, linear vector function we try to create. So I can just say like this. Okay, and SCPI is the package. So I'll say Python 3 py reverse modify. Now it would go ahead and in this function, in this file, it would generate a module diagram and highlighting this class. Okay, so it will try with the kind of all level of association and inheritance, and at the end it would kind of, if it times out, then it would try other way. Okay, it times out. Now it is trying with association level 1. Okay, so it is done. Now we have a PDF file. It is like this. So scipy.optimize PDF. Okay, much prettier. So this is module diagram. In this module, we have a highlighted class, and only for this class, we have all the attribute and functions. That is this is methods, and this is attributes, and green color means what all are derived. Okay, and so in kind of a skeleton only, it draws the complete module diagram. So this is the benefit we get. We can try same thing with the, okay, so I'll remove SCIPY. Okay, RM minus RF log dir output and SCI and okay, so we can draw now package. We drew a kind of a module diagram. So I can say here differentiable functions dot. Now full optimized we can try with this differentiable functions dot. Okay, we'll try. So full package diagram, now it is trying. Okay, so test also it is trying. We should have ignored the test. Okay, so it timed out. Now it is trying with minus, so one level of association. Okay, let's see if it is able to kind of do our work for a package. I think it is taking a lot of time. So we'll try with kind of some other package. It will take some time. The idea is that we can draw with this tool package diagram with, let's wait for some time. Okay, I think in leisure time we, oh, it did. Nice. No, I think it skipped. Again it timed out. Okay, so we'll try other. So we'll say so we have spatial KD tree. So we'll say spatial package KD tree. This is the class in this package, and we'll say ignore tests. That's it. So it is trying for a package. If it times out, then it will try with one level of association. Okay, so it is trying with one level of association. Okay, so it should, oh, done. Okay, good. So I can see SciPy special kdt.pdf. Now we have a full package. Earlier we saw a module. Now we have a full package. In this package, our class is highlighted, kd, where all the attribute and method is drawn. Otherwise, every other thing is drawn. Just as a kind of, just for a namesake. So we get, in a package, we get class diagram and their relationship so neatly, otherwise it would be very big. If we go for all classes will have property and everything. This is one feature of this tool. Other feature of this tool is all classes in this package it can generate. This is the big thing. Like I can just say special, and everything in this package it will draw and it will club in a file that is handsome. Like there are 22 classes found in this package especially. So all 22 classes it would iterate one by one and it would generate the class diagram. Okay, so I believe it would take some time and probably time for tea and coffee or something. Oh, it is generating. Okay, so it is kind of done. Oh, it is done. Now it is, now if I see the output directory, so if I see output directory, ls output, there is a file called pyreverse.pdf and full class diagram of a package special is available. Okay, so this is a class CKD tree and it has a derived class also. This is what is missing in the class diagram of the Pyreverse tool. In Pyreverse, class diagram doesn't have its derivatives, whereas it shows the derivatives. So nicely it is drawing. Okay, so this is bunch of all classes that is available in a package, and the if class has a derived classes that comes in like QHull user has 4 derived classes. It also comes, whereas it will not come in the traditional Pyreverse. Okay, so before we proceed, I would like to show the this tool again, kind of. Okay, first if with hyphen fix, it fixes the kind of Python code, Python code, and it dumps in a directory like here it dump. Okay, so I'll remove all the SCIPY files. So it dumped everything in SCIPY file. Okay, and then we call modify to actually generate the UML code. That's it. So only two options: fix and modify. Fix to fix everything, and modify start doing the work. We can exclude some classes, like if in a particular UML diagram a particular class is coming too many times unnecessarily, we can exclude that. Timeout we can set association level, ignore, and ancestor level. Pretty simple too. Now if we can do for uh, a package, can't we do for full SCIPY? Okay, so I can say ignore test and just press enter. Okay, 541 classes are there, and all 541 will be clubbed together in a file, and it will be kind of someone can just keep it, browse on a mobile, or it can take it can be taken as a printout. Okay, so it would seriously take some time, kind of in hours. So this is a good time for a break, and we'll be back. Okay, so it is getting over. Okay, so it is doing kind of all the fixes here and there, and finally it would generate the kind of one PDF file that is browsable, printable, can be viewed on mobile everywhere. Okay, so primarily we'll see a class diagram now. So all class diagrams. Okay, so it is available here. Now it's time to browse it. Wow. So this is 537 pages. So that many classes it has drawn. So nicely it is doing. Means if I have a class called numpy doc string, then two classes derive from it, and then it derives from these classes. Okay, so if I kind of there are big classes also, like map wrapper, full SCIPI in one PDF file. So this is really amazing. So nicely it is drawing. This is Radau. Okay, so this class it contains 4 classes. So rather than drawing uh, um, four rectangles in one rectangle only, and all the its labels in one go, it is very useful if a diagram is very big. In that sense, it makes it smaller. Okay, so this class has these many derived classes. Okay, so these are built-ins complex. So that is also built. It draws with all possibility. So built-in complex and okay. So nice. HB info has these many. So this is containment. So these many containment. So it avoids making a diagram too big. So yellow color, and this is built in. Otherwise, this is the class diagram. Okay, so we'll have a a big inheritance class which carries kind of a tail of inheritance. Okay, so I think we have arrived. Like, are we generic? See the class that is inherited from this class. So many. So these are not available in the see this are we discrete. So many classes are derived from this class. Okay, so we'll search what we were looking .hp.hb info. Not available. Okay. .hb.info. So this is kind of a panoramic class. So nicely it is drawing. We can see linear vector function. That's what we kept peeping. Linear vector function. Okay. So this is the class linear vector function. So it is indifferentiable function, and this class has one derived class, and this is the architecture. It looks like it doesn't derive from anyone else. It contains matrix and it has hierarchy. We'll see KD tree also. Okay, very famous class. Okay, so KD tree is a class that derives from C KD tree and generic. It contains KD tree node, inner node, and like this. Means say this is a kind of a circular containment. Means this class contains itself. And means if I see the code, it is really amazing. Means I have no hesitation in browsing the code. Okay, so it is VISCIPY special KD tree, class KD tree. So this is a class, and if I see this inner node where it is kind of circular, it is referencing itself, class inner node. So this class inner node is contained by the KD tree, and there is a kind of two attribute less and greater, and KD tree node create, and there it passes the command line argument, and in the KD tree node create def create KD tree node create. So KD tree is a class in which node is there. KD is a tree is a superclass. KD tree is a superclass under which a node is there, and inside the node create is there, and it returns. Okay, so it returns inner node, it returns leaf node, it returns node. Now this inner node, it contains itself, contains leaf node. Okay, the way it is, this much it is catching. Means genius. It has everything. Just means looking at the code, means Python code is kind of, it's very implicit. It's not very explicit the way C and C++. Still it is drawing. Top class. Okay. Other panoramic class we have like okay, it is in Interpolate package. Okay, so built-ins float, built-ins complex, everything. So okay, so this class derives from Interpolate 1D. So interp 1D. Okay, and this is there. So nice. So I have kind of one PDF file and everything is inside the PDF file. Okay, so we covered almost all points. So this is the how Pyverse think about the package hierarchy, whereas okay, so only thing remaining is I have to download the GIT Hub sklearn repository and we'll run fix on it. It would fix Python and Python code, and finally same modify step we need to follow. That's it. So we covered all the points.
Contact us for UML training, for designing training, for Python training, for OpenGL training, or machine learning.